Good guys, welcome back to this class and good afternoon everyone. Okay, so guys, remember that when you started doing mechanics mathematics and you reached where there's a part you needed to apply differentiation and also integration in solving. You needed to apply these two concepts here in order for you to solve questions on displacement. You also needed to solve questions on velocity, questions on acceleration. Yeah, so you remember that there was a topic where you needed, first of all, the concepts of differentiation and integration for you to be able to solve questions. That, if you remember very well, that was topic 3, and the topic is variable acceleration. Variable acceleration. Okay, in mechanics. So you remember that you needed to know these two concepts here before you could solve these two questions. I mean, these three sets of questions here: questions on displacement, questions on velocity, and questions on acceleration. So you needed to know differentiation and integration. Now, what was the main reason why? The reason is because if I take you back, guys, if I take you back, first I write displacement here. Let me write velocity here. And let me write acceleration here. Okay, so look, when we have displacement is nothing but it's just distance that has direction. Distance with direction. That's what displacement is. If you tell me you have covered 10 kilometers and then you tell me in this direction there, this is basically what displacement is all about. Displacement is basically distance that has to do with direction. You moved 10 kilometers southeast. You moved 20 kilometers northwards. You moved 50 kilometers southwest. So all such, that's displacement, okay? So displacement is actually a vector quantity. Now remember vector quantity, what you learned is that a vector quantity is actually a quantity that has both magnitude, which is a size, and direction. That's what a vector quantity is. So vector quantity is actually a quantity that has both magnitude and direction. So all these three guys that I've written here, displacement, velocity, and acceleration, are vector quantities. Now, under this topic, you remember that one of the most important things that you know is change. Okay, this is displacement here. Okay, if I denote it by S, the change of this, so the change of this, the change of S with respect to time, the change of S with respect to time, okay, with respect to time is what we call velocity. Okay, this is what we call velocity. So S dividing time, that's velocity. This is what we call velocity. So velocity is nothing but just the change of displacement with respect to time. Okay, that's what velocity is. Now again, so that's what velocity is. You're just talking about the change of displacement with respect to time. So if you're moving like this, so you're moving in this direction here, like the way I've indicated, you're moving in this direction here. Okay, so the moment you start changing this displacement here, maybe 10 kilometers per hour, 10 kilometers per Yeah, so you're talking of displacement, which is just the change of distance with the direction in relation with the time. So velocity is the change. Velocity is the change of displacement with respect to time. That's what velocity is. Now, when you're talking of velocity, you come to acceleration. Acceleration is nothing but also the change of velocity with respect to time. So the change of velocity with respect to time. Okay, so acceleration is a change of velocity, with respect to time. That's what acceleration is. So you can see how we are moving. From here, if we are talking about, so you've seen how we're moving here. From here, this is displacement. We talk about the change of this displacement with respect to time, we are here. We talk about the change of this velocity with respect to time, we are here. So you've seen here how it works. So this change here with respect to time, you come here. This change here with respect to time, we come here. So in mathematical terms, if I denote displacement as S, okay, that is S, which is displacement. If I want to talk about velocity, we said velocity is the change of displacement with respect to time. So in mathematics, that is differentiation. So if you are moving from here to there, you move from here to there. In mathematics, you are just differentiating. So when we say differentiation in mathematics, we just mean the change. That's what differentiation is. Differentiation is a mathematics of change. So differentiation is the mathematics of change. Differentiation is a mathematics of change. What do I mean by the mathematics of change? So whenever you're talking about displacement, okay, whenever you're talking of displacement, okay, maybe displacement, you denote it with a function like that. You say this is displacement, okay? This is displacement here. So if you want to talk about the change of this displacement here, in mathematics, the change of this displacement, like I said, is velocity, right? So meaning you're just differentiating. You just differentiate this. So when you differentiate, what you get is velocity. And then again, when you have velocity, if you want to talk about acceleration, when you just differentiate your velocity, you are on acceleration. So you've seen the relationship. So we have displacement here, we have velocity here, we have acceleration here, okay? So in mathematics, we denote it by this differentiation, which is D. We denote it by D, that's differentiation. So now here you are dealing with differentiation of S. So differentiation of S. Now, differentiation of S with respect to what? With respect to time, because displacement is changing in relation with time. So you're talking of differentiation of S with respect to time. I'll denote time by T. So we denote it by this. So here we talk about the change of displacement with respect to time, then we are here, which is velocity. So this is basically what velocity is. Then when we are here, we talk about the change of this with respect to time. So we are talking of the change of V with respect to time. So basically, when we say that the change of velocity with respect to time, that's what acceleration is. So you can see we have this S here, we have V here, we have acceleration here. We want to move from S to V, we are just differentiating S with respect to time. We want to move from V to A, we are just differentiating V with respect to time. That's what we do. But you see, we also have opposite in mathematics. We also have opposite. If I want to go back now to move from acceleration to velocity, we say we are integrating. That's the opposite of differentiation. We say we are integrating. So if the symbol is denoted by that, it looks like some S kind of a form. So we are integrating. So when I'm integrating, it's like integration is going back. So I'm moving from A back to V. So I'm integrating. Then I'm moving from, so I'm integrating this acceleration. You've seen. So I also want to move from V to S. So I'm integrating. That's going back. Okay, you can see that. So that's integrating. So I'm moving from A to V, I'm integrating. I'm moving from V to S, I'm integrating. Okay, so you've seen the relationship between differentiation and integration. So differentiation is about change. So I want to talk about the change of displacement with respect to time, change of displacement, then I'm talking of differentiation of displacement. I want to talk about the change of velocity with respect to time. I'm talking of the derivative of velocity, which basically is acceleration. And then if you want to go backwards, you are integrating. So before we continue, I want to show you a few things on differentiation. Now, you see, we are not going deep into differentiation. Differentiation is quite a very big topic, and it has so many methods to use when you're talking of differentiating. And we are not, in this course, we are not going deep looking at all methods of differentiation. We are just going to do the first one method of differentiation, which is very, very common that you'll be using each time, actually, each time you're answering questions in mechanics. So we're just using one method of differentiation here. And this is a method that you keep on using. Most of the functions that are asked in your question papers, you guys, they are basically involving this method that we're about to do. And this method is actually called the power rule method of differentiation. Power rule method of differentiation. So what does this rule say? So this rule says that if you have, let's say this is a function, I'll denote it by y. If you want, I can denote a function by f of x, but there's no, so don't think it of anything. So we can denote it by anything. Here we've denoted it by y. I've chosen to denote it by f of x. If it was displacement, I can even choose to denote a function with s. Okay, if it was a velocity function, I can even choose to denote it by v. So remember, these are just letters and variables we are using. There's nothing special about them. Whether I use whether I use y or use f of x. So don't go deep thinking what's the difference, why we're using these letters, or we're using these variables. So there's nothing special about them, okay? So there's nothing special about them, guys. Okay, so this method deals with, we have a function. So we have a function. I'll denote it by f of x. This is a function here, written in that form. Now, this could be a displacement function, okay? So this could be a function that is just, so the displacement that we know, let's say it's being denoted by a function. Or it could be a velocity, the velocity that we know being denoted by a function. Or it may be acceleration that we know being denoted by a function. So don't think so much, guys, on this. So you've seen, so this method of differentiation, it says that when you are differentiating, remember we are differentiating this. Remember I told you that we use D for differentiation. So the differentiation, I write D, we are differentiating what? This function here. Now this function is a function of x, okay? This function is a function of x. So I'm differentiating x in the function. So I'll do this. Remember when I talked about displacement, I said, I talked of where we have displacement, and let's say we are saying we are talking of the change of displacement with respect to time. So I would do this. Now this function here as x is not, what is there is not t, it's x. Okay, so this method, it says that you drop this power on x. So you drop and at the same time reduce. So you reduce meaning you're subtracting 1. So it will be n minus 1. So that's n minus 1 there. N minus 1. Please, this is n minus 1. So this method here is a method of drop and reduce. Drop and reduce by 1. So we have this. So we have this. So I drop n, then I reduce by 1. So that's a method. Drop and reduce. Drop and reduce. Drop and reduce. That's what the method is all about. So if I have a function, for example, like this, guys, 3x to power 4. So now you've seen the derivative is denoted by that. Okay. Now sometimes the derivative of this f of x, we could also denote it by this. F of x with this thing that you are seeing here, prime, just some, yeah. So this is talking about differentiation. So you are differentiating once. Now remember, you can differentiate the function as many times as possible. So this, I'm differentiating once. So I can even write like this. Okay, we can use this sometimes. Okay, if you are differentiating 2 times, so if I put 2 here, it means I'm differentiating 2 times. So it means this, I'm differentiating 2 times. It means this. I put a 2 there between D and S, and then I put a 2 here on top of T. That's to say that I'm differentiating 2 times. But remember here, most of the questions you are dealing with under this topic, you're just differentiating once. So I'm just telling you, when I put 1 prime there, yeah, it means we're just differentiating once. So sometimes we'll denote it by this, sometimes we'll write it by, we'll denote it by this. And there's no difference, guys, whichever. So look, I'm talking about differentiating this. Okay, so if I differentiate this function f of x with respect to x, because it has x, 4 drops, when it drops, it becomes what? 12. Because when it drops, you're multiplying by that 3 there. So it will become 12. Then we have x. This reduces by 1 to become 3. You see? So that's a derivative there. So that's a derivative. I can do one more example. So now here again, guys, the derivative of a constant, or a number, the derivative of a constant or a number is 0. What do I mean? So if I have 3, right, you have a 3 there, the derivative of this 3, the derivative of this 3 here, whether it's a function of t or it's a function of x or anything like that, the derivative of that 3 is 0. So always the derivative of just a number alone, a number standing alone, is 0. But if a number is standing, for example, like this, the number is not alone. Okay, the number is not alone. So you're just differentiating this part. So it only becomes 0 if the number was standing alone. That's the only time we say that the derivative of a constant or a number is 0. But in this case here, it has x squared. It's not alone. So you are only concentrating on this part here. So the derivative, which I can also denote by that, is 2 drops, guys. It becomes 6, right? X, this reduces by 1 to become to power 1. So I can leave it like that. So when I say it drops, I'm writing it as, remember, I'm 2 drops, meaning it becomes 2 times 3, then x 2 minus 1, which is 6, then x, because 2 minus 1 is just 1. So this is mostly the method that you're going to be dealing, with, because sometimes you find that your function, the velocity function, is denoted like this. That is a velocity function, which is just saying this is a velocity function here. So this is velocity. So your velocity is denoted with this kind of a function here. Now remember, we are dealing with the time. That's why you are seeing t throughout the function, because you're talking of velocity here. Okay, now you see, you're talking of velocity, which is the change of displacement with respect to time. That's why it has t in the function. Now you see, if they say find acceleration, okay, if they say find acceleration when time is equal to 5, when time is equal to 5 seconds, I want to find acceleration. Now remember, I told you that when we have displacement, we have velocity, we have acceleration here. If I'm talking of the change of this displacement with respect to time, then I'm talking about velocity, which is this function here, because this function is a change of displacement with respect to time. Then whenever I talk about the change of velocity with respect to time, then basically I'm talking about acceleration. So if the question asks me to say, find acceleration when time is equal to 5 seconds. So what are we doing? Remember, we are on velocity. So we are differentiating, right? Because acceleration is the derivative of velocity. So I'm just going to differentiate this function here. After I differentiate, remember I'm differentiating with respect to t, because that's the variable which is there. So when I differentiate this, remember guys, 2 drops, it becomes a 6t to power 1, because you subtract 1 there, it will just remain like that. Plus, you differentiate this. Now here you take it like the power is, you take it like, remember this, we are taking it like the power is 1. Now, if we take it as the power is equal to 1, 1 drops here. When it drops, it becomes what? It becomes 4. So what I'm saying is this. We have this. So when this drops, it becomes 1 times 4. Then we have t, but it reduces by 1. So it becomes like that. So you see t to power 0. Remember, t to power 0 is just 1. So meaning it's just this that remains here. So the derivative of this is just 4. Plus, remember, this is a constant, it's a number. What did I say? The derivative of a number is what? It's 0. So that's a derivative there. But it's saying that we are finding, so this is acceleration. This is acceleration, guys. What we have gotten, which is a derivative of velocity function, is acceleration, right? It's acceleration, but it's asking us acceleration when time is 5 seconds, meaning your t is 5 seconds, right? Yeah, so acceleration when t is equal to 5 seconds, you just putting where there's t, you put 5. And you end up with what? This is 30 plus 4 gives us 34 meters per second squared. Because remember, that's acceleration. You see, we've gotten the answer. So this is about differentiation. That's the beauty of it. So that's the beauty of it in mathematics. Okay, it allows you to move from displacement to velocity to acceleration. You want to move from displacement to velocity, you just differentiate your displacement function. You want to move from velocity to acceleration, you just differentiate your velocity function. Okay, you just differentiate your velocity function, then you've now moved to acceleration. So that's about differentiation. Okay, that's about differentiation, and this is basically the method that you keep on using most of the times. Okay, differentiation has different methods because we have a lot of functions. Functions are expressed differently, so the way we differentiate them is totally different. Okay, but at this point here, most of the questions you're going to deal with, you just deal with functions of this kind here, where you're just using this method that I'm calling power rule method. Okay, so that's about differentiation. Okay, that's about differentiation. Sometimes you could be given some displacement function, maybe represented by this. That's displacement. So your displacement is represented by that. Now remember, displacement is what? The change of distance with respect to what? To time, right? Yeah. Because displacement is about the distance with respect to time. So you see, this is displacement here, velocity, acceleration. So this is displacement. If they're asking me to find the velocity, I'll just do what? I'll just differentiate this function here. When I differentiate, I'll get velocity. So what do I do? How do I differentiate? 2 drops, it becomes a 6, right? T, because it reduces by 1. This is a constant, it's a number. So it's just like that. If they were asking me to find velocity at a particular time, maybe when time is equal to 10 seconds, I just come and substitute there. Where there's T, I put 10, meaning I get what? I get 60. Okay, it's velocity. So it's what? Meters per second. Okay, it's meters per second. If they ask me to find acceleration, you can see I already have a velocity function here. Okay, I already have a velocity function here, which is 6t. So when I differentiate this function here with respect to time, the derivative is just what? 6, right? Yeah, it's just 6 because you are taking this as 1. I just explained here on how it's becoming just that 6 there. So this 6 you have found is actually the acceleration. Okay, that's the acceleration. So you've seen how we moved from displacement, we go to velocity. From this velocity, we move to acceleration. So you've seen how we moved from displacement to velocity. From velocity, we move to acceleration just by differentiation. You've seen how good differentiation is. Okay, so you've seen how it is. Very, very good and very, very important. Okay, so that's about these guys. That's about this. Let me now talk also a little bit about integration. Remember, I told you. Integration is a way of going back. That's what I told you. You have displacement, you have velocity, you have acceleration. You actually differentiate this displacement with respect to time, you get your v. Then you differentiate your v with respect to time, you get your acceleration, right? And then you want to go back from here to there. I told you we are integrating that acceleration function. We want to move from here to there. I told you we are integrating your velocity function. That's how we go back. So now I want to talk about integration because I've talked about differentiation. So let me now talk about integration. Now, integration will also it has a lot of methods. Different functions come with different methods of differentiating them. But we are not going deep also here in integration because we are only interested in what you are going to use in mechanics. That's what I'm interested in, okay? I'm not interested in going deep. You learn more of differentiation and integration in P1, but I'm not going deep into that. I'm only teaching you certain functions that you find in mechanics exam paper or in mechanics textbook, okay? So even on integration, we are just going to use the power rule method of integrating. So just like the way we have power rule method of differentiation, we also have power rule method of integration, okay? Power rule method of integration, I told you that the integration, we actually represent it with that symbol that looks like S. Okay, so if you are integrating your function, maybe we denote this function here. Okay, this is a function. So you are integrating this function with respect, there's always with respect to either time, in this case we have x, so you put dx here. So this dx here is telling you that you are integrating your function, which is f of x, with respect to time. Or that is one way of saying that your function f of x is in terms of x, okay? So you are sending, I told you that integrating is going back, okay? Going back or sending it back. So this is telling me that you are sending your function f of x back, and your function f of x is in terms of x. That's why we always put that. So what does this general power rule method of integration say? It says that if you have a function, the way I wrote that function there on differentiation, that's a function there. So if I'm integrating this function here with respect to time, this rule says, you remember on differentiation, we said, remember I said drop and what? Drop and reduce. That's what I said, drop and reduce by 1. Here it's, here on integration, the criteria is increase by 1 and drop. Let me demonstrate what I mean. So you are just, this time around, you're not dropping your n, you are increasing it by 1. So you had 1 there. So you have this. You had 1 there. The same thing, you write it down. That's what you do. Now on integral, so the same thing, you drop it down. Okay, the same thing, you drop it down. So if you have, for example, 3x to power 2, and you are told to integrate, so you are dropping it, so you have 3x there. I mean, you increase it, it becomes 3, you drop the same. You've seen that? Okay, now you have 2 things here that I want you to pay attention to. If you are given what you are substituting in, you see, we always write like, this is what you are substituting in. After you found the answer, where there is x, you substitute those values given there. If you are given what to substitute in, you are given what to substitute in. We call these limits of integration. We call them limits of integration. That's what we call them. Limits of integration. This one on top, we call it upper limit. This one down here, we call it lower limit. We call it lower limit. So if you are given limits of integration like this, you leave your answer will always be in that form there. And where you are given limits of integration, we call this part of integration. This falls under what we call, they are called definite integrals. Why? Because you are finding an exact number, okay? At the end, you find a number. So this is definite integrals. So definite integrals, you are given the limits of integration or what to substitute in after you have integrated. So that's about these definite integrals. There's also a part where you are not given, like the way I wrote it at first. Okay, the way I wrote it at first, without anything. There are no limits of integration I've given. Okay, this is, we call this indefinite integrals because you will not substitute anything. These we call this indefinite integrals. This is indefinite way of integrating. And your answer will just be, remember I said you increase and drop. You always put a constant C if you are dealing with indefinite integrals where you do not have limits of integration. So that's about this. This is indefinite integrals. So what do I mean? What I mean is now, let's say we have been given a velocity function. This is a velocity function given by this. So velocity is given by that. Okay, I told you that we have displacement, we have velocity, we have acceleration. If I want to move from acceleration to velocity, I integrate a acceleration function. If I want to move from velocity to displacement, I integrate velocity function. That's what I told you. Now remember, this is a velocity function. Okay, and then let's say we are told to say find displacement. So you've seen we are here. So we want to find displacement, meaning we are integrating, right? So we are just going to integrate this function. We're integrating with respect to t because it has t. It's a t function. So you've seen that we are going to have, this increases by 1, remember, 3t 3 over 3 plus. Now, remember this, if a number is standing alone, okay, when you are dealing with integration, you take this like it is something that is to power t0. Because remember, t to power 0 is just 1, right? So if it's increasing by 1, it's like that increases by 1, the same thing drops down. You've seen, right? So it's like you have 3t because 0 plus 1 is 1. 0 plus 1 is 1 as well. So it remains like that. So I told you that the derivative of a constant, if you remember very well, the derivative of a constant is 0. But the integral of a constant, for example, like 2, if you are integrating with respect to x, the integral of that would just be 2, and then you put x, a constant. So I'm talking about the integral of a constant here, guys. I'm talking of the integral of a constant. If a constant is 4, and let's say you are integrating, the question is talking about velocity, you're integrating with respect to time. Okay, so this would just be 4, you're integrating with respect to t, so it will be just 14. So the derivative of a constant is 0. The integral of a constant will be just that constant with the variable that you're dealing with. In this case, we are dealing with the t, so it will be 40. Okay, in this case here, we are dealing with x. So the integral of that will just be 2x. So that's where this is coming from. 3, we are dealing with the t, so it will just be what? 3t. Now remember, these are indefinite integrals. There are no limits of integration, so I put c. So this that I found here is displacement, guys. This that I found here is just displacement. So what I found is displacement. I can even cancel that, simplify. That is just displacement. Okay, so this is basically what happens. Maybe acceleration function could be presented by this. Maybe 40 squared plus 5t plus 8. This is acceleration function. Okay, And then you are told to find what? You are told to find velocity. So you've seen that velocity is just going to be what? The integral of this, because it's going back. We are here on acceleration. So finding velocity is going back. So we're integrating the function given, the acceleration function given. So then we'll just integrate this function here given with respect to t because it has t. We integrate this, we get what? 8t, right? Plus we integrate this, it will just be 5, right? I mean, sorry. We are integrating, guys. We're not differentiation. We're not differentiating. Sorry. So we integrate this, we get what? 4t. It reduces the power, right? Over 3 plus this also, I mean, it increases the power. This also what? Increases the power, right? This, like I said, it will be what? 80t. Then you put a c, right? Yeah, you put a c. But if they told us that, if they told us that we are finding acceleration between, in terms of time, between 2 seconds and what, 5 seconds, what it means is that you're integrating from 2 up to 5, meaning the answer we have found would have said we substitute 5 first of all, 4, we put 5 there where there's t, over 3, we put 5 throughout. So we have put 5, then we subtract the putting of 2, 4, 2, 3, plus 5, 2 there, 2 plus 8, 2, right? Yeah, and we get the answer, guys. We get the answer using a calculator, but always remember, the answer you are getting should be meters per second because we are getting velocity. So it has to be meters per second. Is that okay? So this is basically about differentiation and integration, okay? This is basically differentiation and integration. So you have displacement here, you have velocity here, you have acceleration here. The change of displacement with respect to time, you get your velocity. The change of velocity with respect to time, you get your acceleration. The going back from acceleration to velocity, you are actually integrating your acceleration function. They're going from velocity to displacement, you're integrating your velocity function. Yeah, so this is where we end the class, guys. And with this done, so please try to go through now. Try to go through now that topic there, as we just go through to familiarize yourself before we meet, because as we meet, we'll just go through that topic and talking about the same things over and over again. Enjoy your time, and I wish you the best.